Fired heaters are used to transfer heat. In the furnace, heat is produced by the combustion of fuel at the burners. This heat is then transferred to the process fluid that circulates through the tubes of the furnace. There are three methods of heat transfer: radiation, convection, and conduction. Radiation is the means by which heat is transferred from the sun to earth. Radiant heat travels in waves, as light does. For this type of heat transfer to occur, the object being heated must be in direct line of sight with the source of heat. As with visible light, these radiant heat waves can be reflected. In a furnace, the tubes that are exposed to direct heat from the burners are called the radiant tubes. Heat is transferred to these tubes primarily by radiation. A second method of heat transfer is convection. Convection involves a flow of gas or liquid to carry heat. A central heating system uses this type of heat transfer to distribute heat throughout a room with a flow of hot gases. In a furnace, the tubes that are located above and out of sight of the burners are called the convection tubes. As hot gases rise to go out of the stack, they transfer heat to these tubes. This design increases furnace efficiency by allowing more heat to be used before it escapes out of the stack. The third method of heat transfer is conduction. Conduction is the way that heat is transferred through solids such as metal or glass. This is how heat is transferred through the metal tubes in the furnace to the process flow inside. When heat reaches the process flow inside the tube, a convection current is set up that transfers the heat throughout the liquid in the tube. So there are three different ways that heat is transferred in any furnace: radiation, convection, and conduction. But what determines how fast or how much heat is transferred? While there are several different factors that affect the rate of heat transfer, the most important one is temperature difference. In order for heat transfer to occur, there must be a temperature difference between two substances. The greater this difference is, the greater the rate of heat transfer. Many of the factors that affect the heat transfer rate are due to the design of the furnace and are beyond your control. However, later in the program, we'll look at some of the things you can do to improve the efficiency and utilization of heat transfer in your furnace. Right now, let's consider how heat is produced in a furnace. This is accomplished by a chemical reaction called combustion. For combustion to occur, three things must be present at the same time and in the proper proportions: fuel, air, and a source of ignition. The fuel used in a fired heater may be natural gas, fuel oil, or a combination of gas and oil. Natural gas is preferred in many installations because it is cleaner and burns more consistently than oil. Air is needed for combustion because it provides oxygen that reacts with the fuel. The final thing needed for combustion is a source of ignition. The ignition source provides the heat energy that is required to start the combustion reaction. In the operation of a fired heater, it's important to maintain the right proportion of fuel to air. When this is done properly, combustion will be complete and the maximum amount of heat will be generated without any fuel waste. Incomplete combustion occurs when there's not enough oxygen available to burn all the fuel. When this happens, unburned fuel can accumulate in the furnace, which is a potentially dangerous situation. In addition, incomplete combustion drastically reduces the production of heat. One of the challenges to the operator is to provide enough oxygen to the furnace to allow complete combustion, while at the same time minimizing excess oxygen to assure efficient use of fuel. The key to safe and efficient furnace operations is controlling the combustion process. In an emergency situation, it might be necessary to quickly shut down the furnace. The best way to do this is to remove the source of fuel.
We have seen that by controlling fuel, oxygen, and heat, the operator can control combustion in the furnace.